discussing about the experiments that were led by Faraday in UK and Joseph Henry in USA that led to the birth of the electromagnetism. Here we have got three different kinds of experiments. Let us discuss the experiment number A. In experiment number A, both Michael Faraday and Joseph Henry saw that when there was relative motion between this magnet and this coil, and current was induced in the coil and the galvanometer showed deflection. It was this way: when there was relative motion, when the magnet was stationary, no deflection was seen. That means no current was induced. When the north pole of the magnet was pushed towards this coil, it showed a deflection. When it was moved away from the coil, it showed a deflection in the opposite order. If the polarity was reversed, same deflection was seen, but the direction was opposite to that of that north pole. But when there was relative motion, if this magnetic dipole was stationary, no current was induced. So relative motion is must. In the second case, they saw that if we have a coil with a galvanometer fixed and we have another coil carrying current, when there was a relative motion between this coil carrying current and this coil having the galvanometer fixed to it, when there was a relative motion either towards or either away from this coil, the current was induced in this circuit. That means if the magnetic dipole was held stationary and the coil was moved towards or away from this magnetic dipole, same effects were seen as the magnet was moved towards it or away from it. So here we saw that when there is relative motion between this current carrying circuit and this coil, the deflection was seen as was seen when the magnetic dipole was moving towards the circuit or away from the circuit. In the experiment number C, they took a coil with a galvanometer and a coil with a battery and the key. When the key was pressed, a deflection was seen in the galvanometer, but when the current was fully operating, there was no deflection. When the key was left off and when the key was put off, the galvanometer showed a deflection in the reverse order when it was pressed on. These were the three kinds of experiments that led to the introduction of the electromagnetic induction, which later revolutionized the world by the inventions like the transformer, generator, dynamos. Now here in the experiment number 1, when the magnet was moved towards the coil, the magnetic field lines that were associated with this coil were changing. So the magnetic field associated with this coil was changing, and that changing magnetic field which was associated with this coil induced current in this coil, and the galvanometer showed the deflection. When it was moved away again, the magnetic field lines that are linked with this coil are changing, that again induced the current in the coil but in the opposite direction. Same was case in here. Moving charges or the current produced the magnetic field. When there was relative motion between this coil and this coil, the magnetic field lines that were linked with this coil were changing by the relative motion, and that change of magnetic field that was linking with this coil induced current, so the galvanometer showed the deflection. Talking of the case number 3, we have that when we put key on here, that is the current rises from 0 to maximum value, so the magnetic field was changing, and when the key was put off, the current dies from maximum value to 0 value. That means the magnetic field lines that are associated, or the magnetic field associated with this current is changing from maximum value to 0 value. That change in magnetic field was linking with this coil, and that showed the deflection during putting off the key. So during passing on the circuit and putting off the key, the current goes from maximum value to 0 value and 0 value to maximum value. That means the magnetic field that this current is producing goes from 0 value to maximum value and maximum value to 0 value. That change in magnetic field is linking with this coil, and that changing magnetic field which is linking with this coil produces a deflection in the galvanometer, or we can say that induces current in this circuit. So in all the three experiments, it is clear that it is the change in magnetic field that is linking with the coil that induces the current. It is not the magnetic field, it is the change in magnetic field, because here in case number A and case number B, we have got the relative motion between the coil and the magnet, or between the coil and the current carrying coil, and in case number 3, it is the rise of the current from 0 value to maximum value and the decay of the current from maximum value to 0 value that changes the magnetic field that is linking with this coil, so the deflection is produced.